Hello everyone, we're getting back in the swing of things with find peak element. A peak element is an element that is strictly greater than its neighbors. Given a zero-indexed integer array nums, find a peak element and return its index. If the array contains multiple peaks, return the index to any of the peaks. You may imagine that nums -1 equals nums n equals negative infinity. In other words, an element is always considered to be strictly greater than a neighbor that is outside the array. You must write an algorithm that runs in 0 log n time. Okay, so log n, that means no sorting of any kind allowed. So, for example, input 1, 2, 3, 1, output index of 3. 3 is the peak element because it's the only one that goes down on both sides. So, let's look at our constraints. We have nums are 1 to 1000, no big deal. Nums I can be any integer. And nums I is never equal to nums I plus 1. That's a good point. Nums I is unequal to nums I plus 1. So, edge cases, obviously they called it out. Nums -1 equals nums n equals negative infinity. That's the obvious edge case. Any other edge cases? None stand out off the bat, so let's go to diagram the problem. So, if I have the array 1, 2, 3, 1, and then I wanted to visualize this, we have -1 is negative infinity, and then it shoots up to 1, comes up a little to 2, a little to 3, and then it goes back down to 1, and then it shoots down. Okay, and then let's take a look at this other example. 1, 2, 1, 3, 5, 6, 4. For this one, we have negative infinity, goes up to 1, 2, 1, 3, 5, 6, 4, negative infinity. So we have peaks here, here, and here. Your function can return either index 1 where the 2 is, or 5 where this peak is 6. Perfect. Okay, so we can find the peak by doing a binary search, except that instead of looking at the center number, we'll look at center number +1 and center number -1. So we'll look at 3, we'll find out that it's not a peak, and then we'll look at 2 and find out it is a peak. Now how do I decide if I want to move up or down? If I find out that there's a higher number, then I'm guaranteed a peak is in that direction. If it's a lower number, like 3, 1, well, 1 might go, then 0, -3, infinity, and there's never a peak here. If there's a higher number, it might go 5, 6, 24, but it'll then go -infinity. So I always want to move toward the higher number. And, okay, let me make a note of this. Always move toward the higher number. There may be a peak toward the lower, or may not. The higher will always return to -infinity. Okay, so I'm always moving toward the higher number, and then I was going to say something else. Okay. So def binary peak search. We're going to do peak search here, and that's going to take, I'll just make this non-class function. Okay, peak search is going to need an array and a left and a right, and it's going to return an integer. Actually, we can make this a class function and pass self instead of array, and then here we'll have a array it's been so long since I used Python. So if I do nums self.array equals nums, return 0. I've got my syntax down good enough for now. Okay, so from here I'm going to do return peak search 0 and right is length of nodes. Okay, then here I have mid equals left plus right divided by 2. And then lower equals okay, so I picked up mid. Now I just want to get the values. The mid is my index. Low equals the value self.array mid minus 1. Median equals self.array mid, and high equals self.array mid plus 1. Okay, what happens if these are out of range? If mid equals 0, low equals negative, float negative infinity. Else, there's that. Median equals that, and then if mid equals length of self.array minus 1, then high equals negative 4. Okay. I wish I could do that. Okay, so we pick up low, medium, and high. Then we're going to do if medium is greater than low and medium is greater than high, then we return mid because we found the peak index. Else if, so I know one of these is incorrect, so we're going to do if medium is greater than low, medium is greater than low means that I want to move up, which means I want left to equal mid. Return peak search. Self.peak search with mid plus 1 and right. Otherwise, medium, that means low is greater than medium, which means high has to be lower than medium, and we want to move leftward. So we do return self.peak search 0 and right. No, 0 and mid. Okay. And does that do it? That expected. I forgot a colon somewhere. Oh, elif. I'm a Python programmer, I swear. Peak search is not defined because I made it a class thing. So this is self.array. Integers must be oh. Isn't oh, I need to do integer division. Been so long. Maximum recursion depth. How did that happen? I would have assumed if we start with mid plus 1, so if mid is 0 and right is okay. Print mid right. Run. Where does it get hung up? 5 6 3 6 5 6. Huh? Okay, how is it switching back and forth? When I call with mid and right, mid plus 1 and right, I should get 4. 3, I get 4 plus 6 as the next peak search. 4 plus 6 ends up with a search of 5. Greater than low. Oh. What am I missing here? This ought to give me the correct. We return mid when we have a peak. If I don't find a peak, then I want to look up or down. Okay, let me do a binary search review. Where is that pseudocode? Okay. That's the problem. I bet anything. This is supposed to be a +1. We don't want to go over the same number multiple times. Oh, dang. Okay. Okay, I do a new search on the same array with different numbers. I create a new mid. Okay, so with this one, Okay, so we start off with, how are we starting with 3? Good, because I'm not printing left at all. Left, mid, right. Okay, so we start with 0 and 6, as it should be. That gives me a mid of 3, which is right here. This is okay. This tells me that I should move up, which means I do this one. Left is 4, right is 5, and this should be a success. Didn't I find it? Just a second check. Medium greater than low, medium greater than high. Okay, 1, 3, 5. That's not even correct. Oh, no, it is. Okay. 5, 6, 4, right. Which is what it should be. So, if medium is greater than low, and medium's greater than high. What's... That's a binary operator. I remembered it wasn't double and. I swear I'm a Python dev. Okay. Take that out. And we can go back. Okay. Any other quality of life in here? Nope. Submit. Boom. Beats 100%. 0 milliseconds. Okay. Thanks for joining me. Maybe next time it won't be a million years before I do another one, and I'll get a little better at Python. See ya.